right, I'm going to review simplifying radicals. It's a skill that you learned a couple years ago in Algebra 1, but Algebra 1 was a long time ago, so let's refresh our memory on how to do this. So when we take the square root of something, for example, 4, right? The square root of 4, everyone pretty much knows, is 2. But we're also going to say it's plus or minus 2, and that's because a positive times a positive is a positive. So positive 2 times positive 2 is 4, but also negative 2 times negative 2 is also positive 4. It's the same thing with like the square root of 9. It's plus or minus 3, and that's because it could be positive 3 times positive 3 giving us 9, or negative 3 times negative 3 also giving us positive 9. All right, so these are perfect squares, right? There's no decimal part. If I were to put those in my calculator, I would see that the square root of 4, that's it. I just get 2. It's not 2.56, it's just 2. Square root of 9, it's just 3. And realize that your calculator is not going to give you the plus or minus, so you're going to need to remember to do that on your own. But what if I don't have a perfect square? Let's say I have the square root of 72. So if I'm not sure if that's a perfect square, I can put it in my calculator. And you can see that this one is not, right? There's 8.485281374. Definitely not a perfect square. And I don't want to use that decimal because at some point I've got to round if I use a decimal. And when I round, it makes my answer less accurate, less precise. So we'd rather not round if we don't have to. So this, and I want to get it down to something that's not a decimal. And the way I'm going to do that is I'm going to make a prime factor tree. So remember, prime numbers are numbers that are only divisible by 1 in themselves. When I start to make a prime factor tree, I always start to look if the number's even. That's a simple divisibility rule. If it's even, it's divisible by 2. So I know that 72 is divisible by 2. And I can check this in my calculator because I don't want to make a simple mistake here. 72 divided by 2 is 36. At this point, I can cross out the 72. And the reason for that is because I've just turned 76 into 2 times 36, which is 72. So now if I do my prime factor tree and I keep my even numbers on the left, I never have to worry about the left because they're prime numbers. I can't factor them anymore. But 36 is an even number, also divisible by 2. When I do this number, I can see, 36 divided by 2, I get 18. Again, I'm crossing out the 36 because 2 times 18 is 36. I've already redefined it that way. 18 is an even number. 2 times 9. 9 is not. And if you're not sure of your divisibility rules, if it's not divisible by 2, try 3 next. Then try 5. Then just keep going. Try 7. Try whatever. So here I've got 9. That's 3 times 3. So now I'm done. I have all prime numbers. These are prime numbers. They're only divisible by 1 in themselves. And if I've done this properly, all of these numbers I haven't crossed out should equal the original number. So 2 times 2 times 2 times 3 times 3. So those are all my numbers here. When I push enter, it should equal 72. And it does. So now what I'm looking for is pairs, right? Because here, this was a pair of 2's that equaled 4. A pair of 3's equaled 9. So I'm looking for pairs. So I have a pair of 3's and a pair of 2's. So now think about it, it's Friday night and you only go out if you have a date. So these 3's have a date. They get to go out. These 2's have a date. They get to go out. This poor 2 does not have a date. He's staying home, staying inside. When they come out, they only come out as 1, right? If you take a date, you only go in 1 car. So these 3's, they get to come out, but they come out as a single 3. These 2's come out as a single 2. And this poor 2 has to stay inside. So again, this 3 came from here. This 2 came from that pair of 2's. And this is the 2 that was left without a date and had to stay inside. So now I simplify. 3 times 2 is 6. There's no simplifying between outside and inside. So you're never going to multiply this 6 by that 2. You're just doing outside and inside if you had another inside. So that's my answer. So let's check it. So the way I can check it is I can put my calculator, the square root of 72, and I get decimal answer. And then I put 6 times the square root of 2, and it should equal the same long decimal answer. Now you do need to be careful with this, because typically what questions for is the most simplified version. So let's say on this question, if I had stopped here, let's say I thought 9 was a prime number, and I said, that's great, I can't divide 9 by anything, it's a prime number, I'm done. And so you would have said, I only have one pair of 2's coming out. So you would have had a 2 on the outside. And then you would have said, the 9 and the 2 stay on the inside, and 9 times 2 is 18. And you would have gotten this. Well, when I push enter for that, it is still the same, because it's a simplified version, but it's not the most simplified version. This is the most simplified version. So just be careful with this checking method, especially on multiple choice questions. If you had a multiple choice and you were trying to see which answer works, you're going to want to try all of them. Hopefully that's not your method, hopefully you can do it this way. But if that's your method, you're going to want to try all of them and then look inside to see which is your smaller number. And that would be your more simplified version. So just one more note on this. Let's say I'm not sure of my square roots, my perfect squares, and I'm not sure that that's a perfect square, and I don't put it in my calculator to check. And I start doing my factor tree. So I say, okay, 36 is 2 times 18, cross it off. 18 is 2 times 9, cross it off. 9 is 3 times 3. Okay, I'm down to all prime numbers. I have a pair of 3's and a pair of 2's. And there's nothing left. That's how you know it's a perfect square. So these 2's come out as 1, 2. The 3's come out. There's nothing left inside. Your answer is 6.